Question 7, Part A. We're asked to express 2 sine theta minus 1.5 cos theta in the form r sine theta minus alpha, where r is a positive constant and alpha has to be between 0 and pi by 2 radians. We're asked to give the value of alpha to 4 decimal places. R sine theta minus alpha is r into sine theta cos alpha minus cos theta sine alpha. We can rearrange this to give r cos alpha sine theta, take away r sine alpha cos theta. Comparing this with this gives us that r cos alpha is equal to 2 and that r sine alpha is equal to 1.5. The shortcut for r in this situation is to say that r is equal to 2 squared plus 1.5 squared, square rooted. That gives us 2.5. Dividing this one by this one gives r sine alpha over r cos alpha is equal to 1.5 divided by 2. So that's tan alpha, remember the r's cancel here, is equal to 0.75. And then alpha would be the inverse tangent of 0.75. Remember you need to be in radian mode, so that's 0.6435. So finally we have that 2 sine theta minus 1.5 cos theta can be expressed as 2.5 sine theta minus 0.6435 radians. Now in part B, part 1, we're asked to find the maximum value of 2 sine theta minus 1.5 cos theta. We know that the sine function looks like this. Its maximum value is at 1 and the minimum at minus 1. If we have 2.5 sine theta, then that's just going to be a stretch, so that the maximum is at 2.5 and the minimum at minus 2.5. So we can state straight away that the maximum value of this function is 2.5. Now in part 2, we want the value of theta at which the maximum occurs. This maximum here occurs at pi by 2. So we have to have that theta take away 0.6435 is equal to pi by 2. So theta is going to be pi by 2 plus 0.6435, which is 2.21 radians. Now we're told that the height of seawater on a particular day at a particular location is modelled by h equals 6 plus 2 sine 4 pi t over 25, take away 1.5 cos 4 pi t over 25 for t between 0 and 12. And t is the number of hours after midday. We know from above that we could write this as 6 plus 2.5 sine 4 pi t over 25 take away 0.6435. In part C, we want the maximum value of h predicted by this model. Once again, we know that sine has a maximum of 1, so the maximum of this part of the function is 2.5. Add the 6 gives us h is 8.5. We also want the time that this occurs. From the first part of the question, the second part of the question, part B, we know that 4 pi t over 25 take away 0.6435 needs to be equal to pi by 2 to give us the maximum. So 4 pi t over 25 is pi by 2 plus 0.6435, and then t would be equal to 25 into pi by 2 plus 0.6435 divided by 4 pi. Calculating, that gives us that t is equal to 4.41. Now in part D, we're asked to calculate to the nearest minute the times when the height of the water is predicted to be 7 meters. So 7 equals 6 plus 2.5 sine 4 pi t over 25, take away 0.6435, bring the 6 over and divide by the 2.5. So we get sine 4 pi t over 25 take away 0.6435 is equal to 1 over 2.5. So the inverse sine of 1 over 2.5 is going to be equal to 4 pi t over 25 take away 0.6435. Now, the inverse sine of 1 over 2.5 gives us 0.41 radians. We're probably going to need the secondary value as well. 0.41 is here. For a sine which is positive, we're going to need the second one in the S quadrant, such that this is 0.41. So the angle is pi, take away 0.41. So we're going to get 4 pi t over 25, take away 0.6435 is 0.41, or it's equal to pi take away 0.41, which is 2.73. I'm actually going to use more than I've written down here of these numbers. Rearranging by adding 0.6435 to both of these, then multiplying by 25, then dividing by 4 pi, gives me that t is either 2.096 or t is 6.711. So this is going to be 2 hours and then 0.096 times 60 minutes after midday. So this one gives us 14.06. This one is 6 hours, which would take us up to 1800, and then do 0.711 times 60 to get the minutes, giving us 1843.